Businesses need a capacity management solution that empowers IT administrators to become more agile and adaptable in responding to resource demand and supply fluctuations. IT also needs to have comprehensive visibility into current capacity to better forecast future capacity of the different object types. VMware vRealize Operations Manager helps you apply demand and allocation capacity planning principles while managing the capacity of your virtual and cloud environments across any object type. Let's examine this using a virtual machine. Allocation is the total amount of a resource you configure to the VM. Demand is the amount of that resource the VM is presently asking for, and usage is the amount of that resource the VM currently receives. When demand is higher than usage, the difference between the two is resource contention, something that can negatively impact application and workload performance, especially as contention continues to build. If your environment can accommodate X number of VMs and you're only running a smaller number than X, then you have room to grow. You may also have chosen to have extra capacity to accommodate failover or other possible scenarios relevant to your environment. Either way, having this clear visibility into capacity is critical. When usage is higher than demand, there are opportunities to reclaim capacity if you choose to. This translates to idle VMs, powered off VMs, or VMs that need to be right-sized. For example, let's take a cluster that has been allocated 16 gigabytes of RAM. This cluster's workloads are currently demanding 11 gigs to meet OS and application resource needs, but they're receiving only 8 gigs, clearly not enough to meet their current requests. So the difference between demand and usage, which is 3 gigs, is resource contention. vRealize Operations Manager provides the capability to use both allocation-based and demand-based capacity models. For a production group of workloads, you can use the allocation model to assess capacity risk. You wouldn't want to overcommit resources because you want to manage for performance. For example, in your production environment, you may not want to overcommit memory and possibly have a low CPU overcommitment ratio to ensure that your environment is performing well. For a test group of workloads, you can use the demand model to assess capacity risk. You wouldn't care how much you overcommit because you want to manage for higher density. For example, in your test environment, you may be willing to overcommit heavily to get as many workloads as possible, as long as the environment can continue to run adequately. Using both methods together gives you a clear picture of how much resources your workloads demand, how much of your total physical resources are allocated, and if you are over-allocated, and by how much. The great thing is that vRealize Operations Manager allows you to leverage both of these capacity models in policies that you assign to groups of objects. You can manage the environment for performance, or for higher density and utilization, or both. This deep understanding of demand and allocation requirements will help you gain a more actionable view of immediate and future capacity needs. That way, you can execute capacity changes and purchase hardware or virtual infrastructure on a timely basis. With the agility and flexibility in vRealize Operations Manager, you can now optimize and forecast resource capacity and meet even the most complex business needs and requirements. To learn more about the capabilities of VMware vRealize Operations Manager, visit vmware.com/go/VROps.